Hi, my name is Chris Jarrier. I'm a junior at Taft High School, and I'm currently in Mr. Rasmus's third period chemistry class. I was assigned a problem over the weekend, of which in this video I will describe to you how to work it out.
Okay, so here we have a simple decomposition reaction. Our reactant, potassium chlorate, which is a white powdery solid used in labs to speed up reactions, is applied with heat. Out comes our product, which is potassium chloride, also a white powdery solid, and oxygen. To further explain this is our reactant, potassium chlorate. Notice the 8 at the bottom here because of the subscript 3. This is a... Now on to our product. First part of our product is potassium chloride. Notice the "ide" because of the missing subscript here. It is implied that there is only one, therefore "ide." This is also a white powdery substance, solid, used in labs. Clearly in this equation is our second product, 3 molecules of oxygen, which is a gas, clearly depicted here. Now, to figure out this equation, we must know our knowns. In this particular problem, I am using 6.54 grams of potassium chlorate to determine how many molecules of oxygen there are in this equation. Among our knowns are our conversion factors, which are essentially our mole ratios. Now as far as our unknowns, that is what I'm going to be trying to solve. Our molecules of O2 per 6.54 grams of potassium chlorate. To do this, we are going to use science. Now yes, science includes math. So, you might be asking, what is all this mumbo jumbo? Well, I will further explain it. But basically, all this math includes our converting factors and our mole ratios to determine how many molecules of O2 we have. So, in this math, we have step 1. Determine your converting factors, which are our mole ratios. Now, we're going to use this to determine our first part of our mole ratio. Now here, depicted for mass for moles, we have 1 mole over molar mass. And then we can use, on our second part, our Avogadro's number over 1 mole to get our representative particles, which are our molecules of oxygen. So after a little bit of math, which I chose not to explain, we have 1 mole of KNO3, potassium chlorate, over 123 grams of KNCO3. 1 mole over our molar mass. Step 2, write your equation once you have all your factors. What are we figuring out? So if it isn't clear at this point, we are figuring out how many molecules of O2 and 6.54 grams of potassium chlorate using our converting factors. As I was explaining, we have included Avogadro's number over 1 mole of oxygen to figure out molecules of oxygen combined with the rest of our equation. So once we put together this equation, we will do a little bit of math and eventually some of our numbers and factors to determine our answer. Once you have eliminated most of your factors, it is time for your answer. After a little bit of math, you can determine your answer, which is molecules of O2 and 6.54 grams of potassium chlorate is 4.8 times 10 to the 23rd power. This number is based on Avogadro's number when we had it here. Somehow math and wibbly wobbly science things answer.